Hi everyone. Welcome to the first episode of Serverless in Real World, video series presented by SlapForge. In this episode we are going to build a web-based SMS sender, using serverless technologies. When we are developing software solutions, an SMS sender can be a handy tool for various use cases. So, before going into the implementation details, let's see some of the popular use case scenarios of an SMS sender. An SMS sender can be used to notify the users of your application regarding some critical alerts. Or, if you are developing a security-critical solution, an SMS sender can be useful for sending one-time passwords to the users. In addition, SMS senders are mostly used by the applications to send promotional notifications to the subscribers. In all these use cases, we can notice a common characteristic, which is that the SMS sender is not an application which is invoked very frequently. Therefore, if we are to use a server, which is running continuously to host our SMS sender, it will sit idle most of the time, but costing us for the resources allocated to that server. Therefore, the best approach to deploy this solution is in a serverless platform, so it will become active only when required. Because of that, in this video, we are going to use AWS serverless technologies to implement our SMS sender. Now, let's have a look at the high-level architecture of the solution we are going to develop. For this, we are going to use three AWS services, which are AWS API Gateway, AWS Lambda, and AWS Simple Notification Service, which is also known as SNS. The AWS API Gateway will receive a POST request similar to this, and it will then invoke the Lambda function with that request payload. The Lambda function will extract the message, mobile number, and the sender ID from the payload first. Then it will invoke the SNS service to send the SMS out. Additionally, we can also integrate AWS Cognito service to control the access to our API. But since we are not interested in API access control yet, we are not going to cover that in this video. To develop and deploy the serverless solution, we need to use a proper serverless development toolkit. In this video, we are going to use SlapForge Sigma, which is a browser-based IDE for serverless development and deployment. Let's see some of the reasons to choose Sigma as our development tool. Since it is completely browser-based, we don't have to install any frameworks or software in our local machines. We only need a web browser and an internet connection. Sigma provides a centralized interface to manage all the AWS services we are going to use in this solution. So we don't have to switch between different consoles to configure each service. Sigma also provides the capability to test and debug our code, so we can make sure that our code works correctly with a click of a button before we deploy it into our AWS account. So let's start our development by accessing Sigma from our browser and login. If you don't have a Sigma account, you can create a new one very easily for free. First, we are going to create a new Sigma project for our application by providing a name. We'll name this project as SMS Sender. Let's keep AWS as the base platform, and you can choose any of the AWS regions to deploy this project. For this video, we are going to use US East 1 region. Then click on Create Project button. Now we are inside the Sigma editor. On this panel on the left you can see the various AWS and other services supported by Sigma. We can use these services in the code, just by dragging and dropping. Then if we go to this project tab, we can see that Sigma has already created a JavaScript file called lambda.js for our Lambda source code. If we want, we can rename this file, change its parameters such as timeout, or even add more lambdas as well. Since we need a single lambda for our SMS sender, we are going to use this file without any changes to the default settings. So if you remember our architecture diagram, the first task is to add an API gateway and configure it to trigger the lambda when a request is received. For that, let's click on this API gateway service block and drag it onto the event parameter of the lambda handler. Once we drop the block, we get this pop-up dialog to configure our API gateway endpoint. We are going to use an entirely new API for this application. So let's provide the name SMS Sender API as the API name. Then we keep the endpoint type as edge optimized, and configure the resource path as send SMS. Since we are going to only allow POST requests, let's choose POST as the method, and then name the deployment stage as test. Now, if we expand the Show Advanced panel, we get two other options to enable. If we enable Lambda proxy integration, Lambda will receive the entire HTTP request received by the API gateway, with headers, query parameters and other details. But since we are only interested in the request payload, we are going to keep Lambda proxy integration disabled. If we enable CRS, Any browser-based HTTP clients also can access our API endpoint, which can be useful. So we are going to enable CURS for this API gateway endpoint. Now when we click on this inject button, this API gateway endpoint will be added as a trigger to our Lambda function. Our next task is to extract the necessary parameters from the request. When the API gateway triggers the Lambda, the request payload of the HTTP request will be the value of this event parameter. So we can get the receiver, sender and message values from the event object as this. As a good programming practice, let's also add a console log line indicating which message is being sent to which receiver. Now we have the message, intended receiver and the sender ID in variables. So as our last step of the implementation, let's add the SMS sending code to our Lambda. For that, let's click on this SNS service block and drag it onto the editor and drop here. SNS provides a couple of resource types. Since we need to send SMS directly to the phone numbers, let's select the direct SMS as the resource type first. Then we are supposed to add the mobile number of the intended receiver to this mobile number field. If you look closely, you can see that this field has a small X symbol at the end. In Sigma Editor, such fields can be used to set constant values as well as values from defined variables. For example, we can provide a specific value for the number as this. If we use this way, all the messages will be sent to this number. But what we actually need is to set the receiver variable we defined earlier to this field. To do that, all we have to do is type its symbol, followed by open parenthesis like this, and Sigma will list all the available variable names. Then let's select receiver and press enter to insert it. Similarly, we can set the message variable as the value of this message field. Then we need to select a message type here. SNS provides two message types for SMS messages as promotional and transactional. For promotional type, SNS optimizes the message delivery to incur the lowest cost. So that type should be used for non-critical messages, such as marketing messages. For transactional type, SNS optimizes the message delivery to achieve the highest reliability. Therefore, if you are dealing with critical messages that support customer transactions, such as one-time passcodes for multi-factor authentication, you should use transactional type. Since we are not really dealing with critical messages here, let's keep the message type as promotional. Then we can set the sender ID from the sender variable, as we did for mobile number and message fields. This sender ID will be displayed as the message sender on the receiving device. But the support for this sender ID varies by country and/or region. You can check the AWS documentation to see if your country or region supports that. Now we can inject the code to the editor by clicking on this inject button. Then let's implement the callback functions of this generated code by adding some console logs and then moving the Lambda callback inside them. Now we have completed our implementation. But before we deploy this to our AWS account, let's use the testing functionality of Sigma to do a quick test to verify our code is correct. So first we have to create a test event. We are going to set our expected JSON payload as the event here. Then we can invoke the test by clicking this test button. Now we can see the Sigma Trails panel here and it shows the result of our test invocation as a success. And if you check the phone, you should have received an SMS as this. Since our code works well, we can go for deployment. To invoke the deployment, we can click on this deploy button on the top. As the first step of the deployment process, Sigma is going to save our code to a version control system such as GitHub or Bitbucket. We are going to use GitHub to save our code, so we have to authenticate Sigma to use our GitHub account. Once authenticated, we can see that Sigma is going to save our code to a repository named SMS Sender, under our GitHub account. If we want, we can change this repository name from here. Then we are going to provide a commit message and click commit. Now Sigma has checked our GitHub account and says that there is no existing repository with this name, so it will be created. If we want, we can change the repository name from here as well. Also, if required, we can ask Sigma to create it as a private repository by toggling this switch here. Once all the details are correct, we can click this button and Sigma will initiate the commit process. While we wait for the commit process to complete, we can check what's going on by these notifications at the bottom left corner. Now Sigma has successfully saved our project to the repository and it has also built our deployment bundle to be deployed. So in this table we can see what are the components that will be deployed to our AWS account by Sigma as this project. If we are okay with them, we can click on this execute button and the changes will be deployed to AWS. Now we can see that the changes have been successfully deployed to the AWS account. Here we can also see the endpoint URL for the API gateway endpoint we deployed to accept post request. So let's copy it and try sending a sample request. You can use any HTTP client to send this request to the API. Here we are going to use Sigma's inbuilt HTTP client and let's see what happens. Great. It says that the message was sent successfully. So if we check our phone, we should be able to see an SMS with this message. So that's it. We now have a fully serverless SMS sender, which we implemented only in a couple of minutes.